Hello again, everyone. Hopefully we're all feeling as good as we can hope for coming off of our second exam. I know it's a tough one in there, but we're going to keep moving here, going on into chapter 6, where we're talking about some of the applications of trigonometry, some of the more advanced uses of trigonometry, which I know is going to sound ridiculous to you guys because this is tough stuff the first time you see it, but it does get more involved, either for better or for worse, depending on your perspective at this point. Anyway, in section 6.1, we are moving on to talk about a thing that we call the law of sines. The law of sines is an approach that we use for dealing with triangles that are not right, as it were. That is, we're talking about oblique triangles, where we have certain arrangements of information that we can know that naturally can be used to find other amounts of things. We're talking about solving triangles, where we are given things like angles and side lengths and want to be able to find what we don't have in terms of the other angles and side lengths. We have a few different things we can do with that, and ultimately it'll lead us towards ideas of areas of oblique triangles, but that's one thing we can look at. The next is talking about the law of cosines, which is, again, for these types of arrangements, getting things where we know, say, a side, an angle, and then a side, or all three sides, and want to get the other side lengths, other angles, just anything that we don't have. We can use sine and cosine in some special ways to get there, where kind of these things can be considered as extensions of the Pythagorean theorem and extensions of the Pythagorean identities to more general, right-angled cases. But once we have those, we'll then look in section 6.3 at a way that we can redefine position in terms of angles and radii that kind of get hinted at a lot when we're talking about the unit circle back in chapter 4, which is what's called the polar coordinate system. We're going to be looking at how we can recognize and identify locations, that is points, in the polar plane, as well as how we can do conversions between our more comfortable rectangular system and the newer polar system. So, for this week, we've got our more or less normal things up to some important adjustments that we've got a worksheet due by the end of this week for getting some introduction to this material, as well as some problems in my lab, which normally would be due next week, but I'm pretty sure I adjusted those deadlines a little bit due to some circumstances that I'm sure none of us are disappointed to be reaching at this point in the semester. And then from there, instead of a pre-assessment, I have something a little bit different planned for you guys, where because we're about halfway through at this point, we've seen actually about half the material I'm going to get to in this class as a whole. We're going to finish off with a feedback survey about how things are going. Maybe you give me some ideas that could help out down the line or help out if I teach this class again, but it's a chance for you guys to let me know how things are instead of, the normal assignment you get there. And that's not going to be directly for a grade, but it will have some drops attached to it that I'll talk about later to give you guys some ideas of what's going on. There's also a challenge problem mixed in there somewhere, but because this is our second one, I don't talk too much about extra credit. Well, I'm leaving you guys to find out about that. Anyway, let's get to work here looking at chapter 6. See you in there.